Waters Algebra. Here's Mr. Lawrence's review lesson for Chapter 9. This one should be real easy. It's basically polynomials and factoring. Remember that polynomials are classified by degrees. We have an error here. Hold on 1 second. Now remember something that's to the first degree, like x plus 5 is linear, right? I have an x squared plus 5, that would be quadratic. I don't know that I mentioned this one a whole lot, but this would be cubic. All right, there's a name for the fourth power, which is quartic, but we're not going to use it a whole lot. All right, and that's, of course, this is first degree, going by the highest power, highest exponent, that is. This is second degree, and then cubic is third degree. Okay? All right, so let's back up here. To add these, we're going to combine the like terms. So I'm going to get out some highlighters here. It looks like I've got some x squareds here, or some x squareds there. Plain old x with plain old x. And then I also have constants with constants. Now I notice that there's only one term that's x cubed, so I'll just bring him down. The one's highlighted in the bluish kind of color. There's 5x squareds over there and 2 more x squareds, so now I have 7x squareds. In yellow, looks like I have a negative 2x, and the greens are going to yield a negative 3, and there you go. Okay, this would be a polynomial. It has 4 terms. Remember, one term is a monomial. 2 terms would be a binomial. So I should put the meal on the end of there. And 3 terms would be a trinomial. And more than 3 terms, we just simply call it a polynomial. And it is cubic because its highest power is 3. This one here, a lot of you will make a mistake. You'll forget to distribute this negative. This negative belongs to all 3 of these terms. So I'm going to distribute them here, here, and here, which basically means that this is going to become positive. Change signs. And now it'll be a lot easier to do it just like the problem I did up above. So let me see here. X to the 7th, I don't see any other x to the 7th. X to the 6th, I don't see any other x to the 6th. X squared, so I got 4x squareds there, and I've got 4 more x squareds. And it looks like that's all I'm going to be highlighting. So I've got 12x to the 7th minus 5x to the 6th. Minus 8x to the 5th plus 8x squared. Should I cancel those 2 out? No, because they're not like terms. One's x to the 5th and one is x squared. All right, and then a minus 2x. And that, ladies and gentlemen, is my solution. All right, I don't think I have anything else on this page. I'll go to this page. And this is a distribution problem. Hopefully you remember that. I have to distribute here and here. And this will result in 15x cubed plus 18x squared. This problem I would call a FOIL problem. Hopefully you're really good at foiling by now. First, outer, inner, last. My first give me 15x squared. My outers give me a negative 25x. My inners give me a positive 6x. And my last give me a negative 10. And when I combine like terms, I get this answer. And there you go. Pretty simple stuff. All right, now I'm combining 2 things. These are all factoring problems, but I also have to solve. Now on the midterm, or on the final, I should say, you're going to have to factor some, you're going to have to solve others. Now I know a lot of you are going to want to use the quadratic formula, but if they require you to solve by factoring, then you're going to be in trouble. So, and actually I think I've got a couple problems hidden down. Yeah, there's one more problem hidden down there. Okay, so I'm going to solve all these by factoring if possible. All right, well this first one I'm going to factor. It looks like the only thing I can do is factor out an x. And that's going to leave me with a 16x plus a 9. That's going to equal 0. Right off the bat, I can see that x equals 0 is one of my answers. And then I can set this equal to 0. 16x plus 9 equals 0. 16x would equal negative 9. X would equal negative 9/16. And there is my other solution. Okay, so remember I'm doing two types of problems at once here. I'm doing factoring problems and I'm also solving them. All right. Oh, this pattern here, x squared minus 25, that's the difference of perfect squares. So that's going to factor as x plus 5 as a quantity and x minus 5 as a quantity. And that means x is going to equal plus or minus 5. Okay, if I look at this one, I've got a perfect square trinomial. X plus 3, quantity squared equals 0. Means x is going to equal negative 3. How do I know that? Because it's a perfect square trinomial. This is a perfect square. That's a perfect square. Square root is 3. Square root is x. So I'm going to have x and 3 in both quantities. And when there's a plus in the back, that's my Wendy's double stack. I'm going to have x plus 3 and x plus 3 again. I prefer to write it as one quantity to the second power. Okay, jumping up here. Guess what? I've got the difference of perfect squares. That's going to be 2 minus 3x and a 2 plus a 3x. Now I'll solve. 2 plus 3x equals 0. 3x is going to equal negative 2. X is going to equal negative 2/3. Okay, if I solve this one for 0, I'm going to get positive 2/3. So x is going to equal plus or minus 2/3. All right, there you go. Okay, coming down to this one. Looks like it's a perfect square trinomial again. This is a perfect square. That's a perfect square. 6x doubled is 12x. It's going to be x minus 6 quantity squared, or times another quantity, x minus 6, which means x is going to equal 6. There we go. I am going through this really quick, but I expect you to have mastered it. All right, this one here. This is the one where I have to list the factors of the first term and the factors of the second term. Excuse me. That should be a 2 and a 2, shouldn't it? All right. And I'm going to have to, after I multiply, subtract my products to get a positive 5. Well, let's see. 6 minus 4 isn't going to work. Oh, I got it. An 8 and a 3. 2 times 4 is 8. And that's a 3. And I want an 8 minus a 3. All right, so when I go to factor this one, I know I'm going to have a 2x and a 3x. I know that the 2 gets multiplied by the 4. Shoop. I know that 3 gets multiplied by a 1. I need the 2 times 4 to be positive, and that to be negative. That equals 0. So, solving the first one, x would equal 1/2. And the second quantity will give me negative 4/3. I did that rather quickly because I know a shortcut. If you haven't figured out the shortcut yet, write down 3x plus 4 equals 0 and 2x minus 1 equals 0 and solve them both. Okay, this one here, some of you think it's going to factor as x plus 10, both in quantities. It will not factor that way. Some of you will then realize that and go, oh, they must be negative. Still wrong. You'll change the signs. Still incorrect. This one cannot be factored. Cannot. This one is prime. Therefore, there is no solution. All right. One other thing to watch out for, the problems that have more than one type of factoring embedded in them. For example, 18x cubed minus 8x. Factor that completely. Well, I know there's a GCF of x. I also know there's a GCF of 2. When I pull out the 2x, the 18x cubed is going to become a 9x squared. When I pull a 2x out of here, we get minus 4. And so this part factors further. We have a 2x. This is the difference of squares. It's going to be 3x plus 2 is quantity and 3x minus 2. Now I'm not actually going to solve it because it didn't equal 0. Okay, that lesson was a little bit shorter. Chapter 9 you should have already mastered and should be really strong with it. Mr. Lawrence signing off. Good night, everybody.